All right, so in this series of videos, we're going to talk about composition of functions and also the algebra of functions. So specific objectives, we are going to combine functions using algebraic operations, create new functions by composition of functions, evaluate said composite functions, look at the domain of composite functions, and then decompose a composite function into its component functions. So basic math with functions. So we can actually use addition, subtraction, multiplication, division on functions, pretty much just like we do with numbers. So addition is just like you might think. We're going to write f plus g of x, and that's really just saying that's f of x plus g of x. Pretty straightforward. Same thing with subtraction, because subtraction is really addition with a negative number involved. So f minus g of x is just f of x minus g of x. Same story with multiplication. F times g of x is just f of x times g of x. We're going to do some examples right after this. And the one that's a little bit weird is division. So f over g of x is going to be f of x over g of x, but we can't let g of x equal 0, because of course that would cause a divide by 0 error. So we're going to have to modify potentially the domain when we're dividing functions. So we've got an example here. We've got f of x is x plus 3, g of x is x squared plus 2x. And we're going to think of, I'm going to rewrite those real quick. We're going to write f of whatever is equal to the input plus 3, and g of whatever is equal to the input squared plus twice the input. Because that's really what function notation is about, right? So our f of x equals x plus 3, this is linear, our domain is all real numbers, and for our g of x, it's a quadratic. Domain is also all real numbers. We're not dividing by 0 anywhere. We don't have any radicals that we got to worry about. So let's go there. There we go. There we go. So we're going to evaluate and give domains for the following expressions. If we want to just evaluate f of negative 2, of course, we're going to say, hey, that's negative 2 plus 3. That is equal to 1. And g of negative 2 would be negative 2 squared plus 2 times negative 2. That's going to be, what, 4 minus 4, which is 0. Now, what about if we try to add these functions together, right? F plus g of x, we're just going to say, hey, I got f, I've got g, and we should simplify that, right? We've got an x squared term, we've got a 2x plus an x, so that's plus 3x, and we've got a constant term. That's it. And our domain for this is still all real numbers, right? Because I can plug whatever I want into there. Now, what is f plus g evaluated at negative 2? So we know that this is f of negative 2 plus g of negative 2, and conveniently we've already figured out what those are. 1 plus 0 equals 1. And that's probably a little bit easier than if we go back to the f plus g function that we just found out. So negative 2 squared plus 3 times negative 2 plus 3 being 4 minus 6 plus 3 also equal 1. So, you know, still comes out the same, but maybe a little bit easier to break it down sometimes. Of course, we have a pretty, not too complicated functions here. All right, what about f times g? Oops, sorry about that. We're going to have, let's see, f times g, x squared plus 2x. And of course, to get the function, we really should multiply this out. We can FOIL it or use the square method or whatever you like. We've got x cubed. We've got 3x squared plus 2x squared plus 6x. So simplifying that, x cubed plus 5x squared plus 6x. Now here's where, and of course still, domain all real numbers. Now here's where our evaluating that at negative 2, we can go back up and say, oh, this is really f of negative 2 times g of negative 2. So that's 1 times 0, which of course is 0. And that's a lot easier than saying, oh, I'm going to plug -2 into my function and evaluate it, because this would be what, -8 plus 5 times 4, which is 20, minus 18, sorry, 12. Now I'm like, wait a second, which is 0. Easy enough. Okay, so one last part on this guy here. We're going to do our division. All right, we got f over g of x. So we'd say, hey, that is x plus 3 over x squared plus 2x. Right? And not a bad idea to factor. I've got a x in the denominator that I can pull out, because what that does is remind me about what x values can I not plug in. So our denominator is equal to 0 if we plug in x equals 0 or x equals -2. So we can't have, we've got to exclude those from the domain, right? So our domain, and I'm going to use inequality notation because it's easier to say x can't be 0 and x can't be -2. But that gives us a really easy answer here, because we can say, well, we could say, okay, that was f of -2 over f of g, of 0, g of -2. So that was 1 over 0, which of course does not exist. But then we say, wait a second, we just excluded -2 from the domain anyway. Which is why it's not existing, right? Not in domain. All right, so that's a good place to stop since we've finished this problem.